Welcome to part 3 that is focused on Jenkins. Now that we understand the concepts of continuous integration and continuous delivery and deployment, the next logical question is who performs all this automation? After a developer pushes the code, who starts the build, who executes the test, who generates the reports, who sends notifications, who prepare the application for deployment? So the answer is Jenkins. Jenkins is one of the most popular automation servers. Notice that I use the word automation. Many beginners think Jenkins is a compiler, but it is not. It is not a source code. It doesn't store the source code and replaces GitHub. Jenkins automates everything that happens after the source code changes. Let's return to our food delivery application. Suppose Sarah finishes implementing dark mode. She pushes her changes to GitHub. Without Jenkins, someone on the team would have to manually perform several repetitive tasks. They would download the latest code, compile the application, run unit tests, run integration tests, generate the reports, package the application, deploy it, repeat the same process again tomorrow, and then again, and then again. Imagine doing this manually 50 times every day. It would be exhausting. It would be extremely error-prone. People forget steps, they execute commands incorrectly, different developers follow different procedures, so this inconsistency creates unreliable software. So Jenkins removes this problem entirely. Instead of depending on people to remember every step, Jenkins performs the same sequence automatically every single time. Think of Jenkins as a highly disciplined employee who never gets tired. It doesn't forget, it doesn't skip testing because someone is in a hurry, it doesn't accidentally deploy the wrong version. Every pipeline follows exactly the same process. That consistency is one of the biggest reasons why Jenkins becomes so popular in the industry. Another important characteristic of Jenkins is that it is open source. This means companies can use it without paying licensing fee. Because it is open source, thousands of developers around the world contribute improvements and create plugins that extend Jenkins capabilities. Today, Jenkins supports hundreds of integrations including GitHub, GitLab, Docker, Kubernetes, Slack, Azure, AWS, Cloud. Rather than performing the software development itself, Jenkins acts as a central coordinator that tells every other tool exactly when to perform its task. This is why Jenkins occupies such an important place in modern DevOps. Now that we have introduced Jenkins, let's understand how it is organized internally. Whenever students first install Jenkins, they usually think everything happens on one computer. For very small projects, that assumption is correct. However, large organizations rarely build software on a single machine. Imagine companies such as Google, Amazon, Microsoft, or Netflix. Thousands of builds may execute simultaneously. One computer could never handle that workload efficiently. This is why Jenkins follows a distributed architecture. Instead of relying on one computer, Jenkins allows the work to be distributed across multiple machines. The architecture consists of two components. First component is a controller, which older documentation often calls the master. Second component consists of one or more agents, formerly called slaves. Although modern Jenkins uses the term controller and agent, you may still encounter the older terminology in books and tutorials or any certification exams. Now let's understand the responsibility of each. The controller acts like a manager of a company. It receives the incoming request, it stores the job configurations, it schedules the builds, it decides which agent should perform each task. However, notice something important. The controller usually doesn't perform all the heavy work itself. Instead, it delegates the work to agents. The agents are the workers. They execute the builds, they run the tests, they compile applications, create artifacts, they deploy the software. So this separation provides several advantages. Suppose one agent suddenly fails. The controller simply assigns future builds to another available agent. Suppose your company suddenly doubles in size. Instead of purchasing one extremely expensive computer, you simply add more agents. Controller automatically begins using the new resources. This makes Jenkins highly scalable. Another advantage involves different operating systems. Suppose your software must be built for Windows, Linux, Mac OS. Instead of installing every operating system on one computer, you can simply create 3 different agents. One Windows agent, then Linux agent, then one agent for macOS. So the controller sends each build to the appropriate machine. That flexibility is one reason why Jenkins is used in so many enterprise environments. Imagine a courier company. Customers place delivery requests. The office manager receives those requests. However, the manager doesn't personally deliver every package. Instead, the manager decides which delivery rider should handle each assignment. Jenkins works almost exactly the same way. The controller is the office manager. The agents are the delivery drivers. When Jenkins receives a build request, the controller first examines the job requirements. Perhaps Docker must be installed, or Python version 3.11 is needed, or a build requires Linux. So the controller searches for an agent that satisfies these requirements. Once it finds a suitable agent, it assigns the job. The agent downloads the source code, it compiles the project, executes the test, packages the software, returns the results. Finally, the controller records the build history and displays the results on the Jenkins dashboard. Notice how efficiently work is distributed. Another important concept here is availability. Imagine one agent suddenly shuts down because of hardware failure. Does Jenkins stop working? No. The controller simply schedules the future jobs on another available agent. So this provides fault tolerance. Similarly, if builds start taking too long because many developers are committing the code simultaneously and administrators simply add additional agents, so the controller immediately begins distributing the work across all available machines. This horizontal scaling allows Jenkins to support organizations ranging from small startups to multinational enterprises. So remember this simple distinction: the controller thinks, the agents work. Now that we have understood the architecture, let's see how Jenkins is actually installed and configured. Now we are moving from concepts to practical implementation. At this point, I would like everyone to look carefully at the screenshots shown on the screen because we'll follow exactly these steps. If you are installing Jenkins yourself, you will perform the same sequence. So the first step is downloading Jenkins. You can choose either of the login type and choose first option for simplicity. After completing Jenkins installation process, a browser tab will pop up asking for the initial administrator password. Jenkins dashboard. Think of it as a control center for your entire automation environment. Whenever you log into Jenkins, this is the first page you will see. Let's briefly understand the most important sections. On the left side, you will notice several options such as new item, build, people, manage Jenkins, and others. We will use these options repeatedly throughout demonstrations in today's or subsequent sessions. The center portion displays all the existing jobs and pipelines. Initially, your dashboard must be empty because no projects have been created yet. So as we create jobs later in this lecture, they will begin appearing here. Near the bottom, Jenkins displays the recent build activity. Whenever a pipeline executes, you will be able to monitor its progress directly from the dashboard. Think of this page as a project management console. Instead of opening multiple applications, Jenkins centralizes the build, execution, the monitoring, reporting, and administration to one interface. Now that Jenkins is installed, we are familiar with its interface. Let's create our first Jenkins job. So first, integrate Jenkins with GitHub. First, make sure you install Git using this link. First, create a new job in Jenkins. Open the Jenkins dashboard and click on Create New Jobs. Now enter the item name and select the job type. For example, item name is Java T point and job type is Freestyle Project. Click OK. Once you click OK, the page will be redirected to its project configuration. Now under the source code management, you will see the Git option if your Git plugin has been installed in Jenkins. Enter the Git repository URL on repository URL option to pull the code from GitHub. Now that you have provided all the details, it's time to build the code. Tweak the settings under the build section to build the code at the time you want. You can even schedule the build to happen periodically at set times. So under build, click on add build step. Click on execute Windows batch command and add the commands you want to execute during the build process. I have added Windows commands, so java c hello world.java and java hello world. When you have entered all the data, click apply and save the project. Now in the main screen, click the build now button on the left hand side to build the source code. After clicking on build now, you can see the status of the build you run under build history. Click the build number and click on console output to see the status of the build you run. It should show you the success message. In summary, we have executed a Hello World program posted on GitHub. So Jenkins pulls the code from the remote repository and builds continuously at frequency you define. Now let's see how to use Jenkins to build and inspect the code. Jenkins next generation plugin helps in analyzing the code, collect all the warnings, and helps us in visualizing the records through pie charts and graphs. So install warnings next generation plugin from first go to manage Jenkins and then manage plugins. Task configuration page will open. At the bottom of this page in the item post build actions, in the list select record compiler warnings and static analysis results. Add new item just as before. You can also use Jenkins to inspect the code using find bugs, PMD or spot bugs and check style. So add new item just as before. Now go to build and invoke top 11 Maven targets. Then in goals set them to clean compile and then this string. Add the post build as record compile warnings and static analysis results and click build now. So you can see the results of static analysis. So we have already covered static analysis tools in the previous lecture. That's it for this lecture. I'll see you in the next session and proceed with further hands-on on Jenkins.